Hello everyone, I welcome all of you once again to the TY BSc Physics Laboratory. Today I shall be teaching you Curie Weiss law for ferroelectric materials. The apparatus that we use in this practical are a 0 to 30 volt regulated power supply, as you can see here, a digital multimeter. In fact, we are using two digital multimeters, one to measure the temperature, another to measure the capacitance, a tube in which we have put the capacitor. The leads of the capacitor are connected to two wires which are brought out, as you can see here, and a thermocouple is put inside to sense the temperature inside the tube where the capacitor is and connect it to the digital multimeter. The diagram of this experimental arrangement is given into the PPT. Please refer to it. Now, in this case, what we have to do is we have to measure. We are actually studying the dielectric that is inside the capacitor. So, the capacitor is put inside a tube and the tube is encased in this. Now, that test tube in which we have put the capacitor is wound with a nichrome wire, and that two terminals of the nichrome wire, one from the top and one from the bottom of the tube, are taken and are connected here to this power supply through this connection, as you can see, this connection. Similarly, even on this side, as you can see, this connection, it is connected to the power supply. So, when you pass current through the power supply, the nichrome wire which is wound around the tube will get heated, and when that gets heated, the test tube will get heated, and when the test tube gets heated, the capacitor that is lying inside the test tube will also get heated. So, there will be an increase in the temperature inside the tube, causing an increase in the temperature in the capacitor also. Now, we are studying the dielectric material which is present inside the capacitor, and we have to estimate the Curie temperature of this dielectric material. Now, here we are using a 0.1 microfarad disc type ceramic capacitor. So, the dielectric material inside is a ceramic material. I hope you know what are ceramic materials. Ceramic materials are materials which have large dielectric constant, and hence they are more used in capacitors. So, the ceramic capacitors available in the market are made up of materials which have their Curie temperature of around 10 degrees to 20 degrees, which is below the room temperature. So, in this practical, we cannot see a direct transition from ferroelectric to paraelectric state. So, the readings that we shall be taking will be in the paraelectric state, but we shall be estimating it from our readings, the transition temperature from ferro to para. The practical is very simple. What we have to do is we have to heat up the capacitor using this power supply by passing the current into the nichrome wire which is wound around the tube, and correspondingly measure the capacitance as a function of temperature. So, if you can see, this one of the digital multimeters is put in the range of temperature, and the thermocouple has been connected here, and the other digital multimeter has been put in the range of measurement of capacitance. As you can see, it is in the range of 2 microfarad, and 27 degrees is the room temperature, and 0.095 nanofarad is the capacitance of the capacitor. As far as the readings are concerned, what you have to do is you have to increase the current in this power supply. So, as you increase the voltage and the current in this power supply, the temperature inside will increase, and you have to allow the temperature to stabilize. So once the temperature inside has stabilized, you should take the reading of temperature as well as the capacitance. But remember, as soon as you increase the current, you should not take the reading. The reason is that as you increase the voltage, the temperature of the nichrome wire will increase because of the passage of current. So initially the nichrome wire gets heated up. The nichrome wire then in turn heats the test tube, and that in turn heats the capacitor. So it takes a little time for the capacitor to reach a stabilized temperature. So once you have increased the temperature to a particular value, once you have increased the current to a particular value, you wait for a few minutes, say 1 or 2 minutes, till the temperature stabilizes, and then measure the capacitance. As you can see here, the temperature is yet not stabilized, it is still increasing. Once it stabilizes to a particular value, you have to note down the value of the capacitance. And you have to keep doing this for different values of temperature. So you have to keep changing the current in the power supply slowly, reach to the desired temperature that you want, and measure the corresponding capacitance. As the temperature will increase, the capacitance of the ceramic capacitor will decrease. So we have to take the measurement of capacitance for various values of temperature, starting from room temperature to say around 70 degrees of temperature. You can even go up to 90 degrees. Okay, so but at least minimum from room temperature to 70 degree is desired. Thank you.